Hello, everyone. Fantastic. Okay, so today, I thought I'd do something slightly different for our live stream. In fact, I hope this goes all right. So what I've got is I want to show you some modeling techniques for how we do modeling with graphical methods, and I'm going to show you three different types of modeling. Remember, there's other ways you can model too, but there's three functions I want to show you how I would model, and we're going to talk about them today. So today I'm going to try and show you my screen in Desmos, so please let me know if you can hear me, and then also let me know if you can see my screen. So my screen will look a little different to what you will experience, but if you would like to try this, if you'd like to try this out after this video, you're more than welcome to go student.desmos.com and type in this code and you can try this out. Your teacher probably will also give you a code like this, but you're more than welcome to try this out when you are ready. Okay. So student.desmos.com and then you type this in. Okay, but let's go through this now and then you give this a go as well. Okay. Fantastic. You can hear and can you see? I appreciate maybe you can see. Also, fantastic. So today, I just wanted to show you how I would model something and how I'd go about doing so. Alright, so the first model I'm going to show you is of this roller coaster section that I've got. Okay, if you can't see the numbers, I'm just going to put it on projector mode. Okay, and so you've got 0, 0 here, 100, 0 here, 15, 8, and 80, 10. So these green dots are points on the curve, and these red dots are x-intercepts that I'd probably want to start using. Okay, so I'm going to do three models. So of my three models, the first one I'm going to do is I'm going to do a parabola model. Okay, because this looks quite nice. So in my parabola model, I'm going to write, what was the code again, Joshua? It is DTE7DX. Okay, yeah. So first model I'm going to do is a parabola model. So my standard form of an equation for a parabola is f of x equals f of x is equal to I'm going to use k x minus m x minus n, where x and where m and n are our x-intercepts. And I'm just going to put sliders on, see what happens. Okay. Now for me, what's really important, because that's blue, I'm going to just change this to a nice solid black. Because that is really important to me. I'm going to use m as 0 as one x-intercept, because this is just a model, and I'm going to use n as 100 as my other intercept, because that, to me, gives me the bounds of what I want. Does it matter if I use y instead of f of x? No, it doesn't, but I prefer f of x. Now what I'm going to do is I know that my k is too big, so I'm going to make k really small, 0.01. Okay, so now I can see it on my screen. But the problem is that it is a model that's the wrong way up. So I am going to make this k value negative. And already you can see that I've got a fairly close model. But what I might do is I'm going to just move k, make it a little bit smaller. So I'll make it 0.5. Oh, that looks really good. But it's at the bottom. I want it to go up the top. and so I might make it 0, 6. And I can say quite confidently, I know it's really hard for you to see, but I can quite confidently say that this model is quite good. I think it's quite good. I'm going to just make it a little bit bigger because I kind of like being a perfectionist. Still going to make it a little bit bigger. And this is just me refining my craft. So I'm going to say that this is my model because it fits this really nicely. Okay, fortunately, it's fit the whole thing really nicely, but it might not always do the same. And so what I'm now going to do is I'm going to type in my model as an equation, because this is what I'll write down. I'll write down y is equal to negative 0.0063 brackets x minus my first intercept, which is 0, x minus my second intercept, which is 100, and I'm going to close the brackets. And this is my equation, and I'm going to put in a domain. I'm going to choose from 0 to 100. Now, you can see that this red line is my model that I'm going to use. This black line is cool, I can turn it off, but this red line is the model that I'm going to say. And now, with that information, I can write down some information. Here goes. Here's a note. Domain is from x equals 0 to 100. Okay, you might want to use less than or equal to symbols there. Okay, then I'm going to type in my range. My range is equal to, well, I look at the bottom, well, the lowest point is 0 for me, and the highest point, I'm just going to click. Ooh, the highest point apparently is 15.57. 15.75. So I write 0 less than y less than 15.57. So that is my domain, and that is my range for my model. Similarly, I will write, really important for me, is turning point. It's also a maximum. And what's the value of that point? That point happens at 15.75. And I'm just going to click that to show you. That's what happens for my model. And then I've got 3 of the things done. My model is symmetric through the line at x equals 50, because if I were to write x equals 50, you can see there's a line and you can see it's symmetric through that line. 1, 2, 3, 4, 5. Domain, range, turning point, symmetry, and of course I've got to do my x-intercepts. My x-intercepts are at 0, 0 and 100, 0 for my model. For the purposes of what I've done, I've spent about 10 minutes, and this is me doing my model and listing my properties. I don't think that this is a huge ask. Now, I will discuss on Thursday's live stream how we write about the fit of my model, but that's not for today. Thursday's live stream, I'll talk about the fit. But today, all I want to focus on is setting in my system, making really good models, and then writing my domain, my range, my turning point, my symmetry, and my x-intercepts. This is all I need. And this is for my first model. Are there any questions? Please ask. I'm going to do my second model. This is what I do for my parabola model. So, my second model that I'm going to do is I'm going to do a cubic model. Okay, once again, I'm going to use f of x is equal to k, x minus m, x minus n, and x minus p. Once again, set sliders up for these. And now, a cubic model is a little harder to do because the numbers need to be even smaller. But one thing I know for sure is m is going to be 0 and n is going to be 100 because those intercepts I don't need to change. And p, because I feel this model is quite symmetric, I am going to do something quite big. But because my arch is symmetric, let's try something like 200, see what happens. Okay, so one intercept is at 0, 0, one is at 100, 0, one is at 200, 0. But now I have to drop k. So I'm going to make k 0.001. That's all right. I'm going to make it 0.001. That's too small. I'll make that 5. And would you look at that? I have a model. And so if I follow it through, I'm quite happy. And I'm going to say that this is my model. Okay, so I'm going to type it in. Y equals 0.0005 bracket x minus 0, x minus 100, x minus 200. Okay, but for me, I'm going to put in a domain because I don't want the whole thing. I don't need everything off to the side. And my domain, once again, is going to be 0 through x through 100. Okay, so I can turn this one off, and so it's just this red line. Sorry, let me just put it on projector mode once again so you can see a little bit more clearly. This is my model. Okay, this model is not as good as my previous model, but I don't mind so much. Okay, and so let's write out what's really important. My domain. Once again, 0 less than x less than 100. My range. Once again, I look 0 less than y, and then I look at the highest point on my model. The highest point on my model is at 19.245. 19.245. Okay? Then what is really important is turning point. For my maximum, and this happens, it's not in the middle this time. It happens at 42, sorry, I couldn't remember that number. 42.265, comma 19.245. That is my turning point. And then I've got two more things. This is a cubic model, and so my cubic model is not symmetric. And then what I want to do is I want to talk about, or there's no symmetry, I want to talk about my x-intercepts as well. My model has two x-intercepts, namely 0, 0 and 0, 100. I know that 0, 200 is an intercept or is a root for my equation, but it's not on my model. And so I'm not going to write it. Once again, 1, 2, 3, 4, 5 properties that I've listed, and this is my model. Are there any questions? And I've also just checked to make sure it's close enough here, and around 80. It's really close. And so I'll talk to you more about how that part works tomorrow. Not tomorrow, on Thursday's live stream. But I think this model is quite good, so I'm going to stick it to there. So, if you notice, I've only spent about 16 minutes so far, and I've done 2 models, and I've written all the key properties for each of these. And so modeling is not too hard. You've got to get an equation, and then you put in your parameters so that it matches up nicely. Okay? I'm now going to do my third model. Please ask me questions if you're stuck, or if you're not sure with what I am doing. Okay? I'm going to give you a few seconds. I'm just going to open this up so you can see. Once again, really important to list all these. Now my third model. Okay, I'll talk about fit tomorrow. Oh, Thursday, sorry. Maybe I should do it tomorrow. I keep saying tomorrow. My third model that I think would be useful for this kind of curve is a sine curve or a sine graph. Okay? And so my model for a sine graph is a sine. Well, I noticed that 0, 0 is a coordinate, so I don't need any other parameters but a and b. Okay? But I know that b is the same as 2 pi divided by the period, which is t. So I'm going to just change that to 2 pi over t. And so now I have to have a new slider for t. Alright? This looks very scary. But let's just look. If I start at 0 and end at 100, the period for a sine curve is how long it takes to go up, down, and up again. And so it's going to be 2 times as long as this part here. So I'm going to say 200 is my period, and the amplitude, A, is the highest point. So at 50, I reckon this is about 16 tall. So I'm going to type in 16. And this is my model. Okay? And once I've done that, I'm going to write my equation. Y equals, y equals A, which is 16, sine 2 pi divided by 200 times x, close brackets. And my domain is going to be, once again, from 0 through 100. And I'm going to just change that to red once again. And put this in projector mode. I keep forgetting, sorry team. And then I can turn my other model off. It doesn't matter. I've got my equation. Now, no one's really asking questions, so I'm assuming you're following along. Now for me, I'm just going to quickly go check and see if everything's tickety-boo. And yeah, I think it's okay. Not the best, but it's okay. I'm going to go with that. And so now I'm going to write my domain and my range. My domain, once again, 0 through to 100. My range is from 0 through y through the highest value of this, 16. Turning point maximum in this case is at 50,16. How do I tell that? I click on here and 15,16. If I zoom in, is exactly where the top of that is. Right? It's a little off. Maybe I should go down a little bit. Maybe I should change it to 15. But you know, if I want, I could. So maybe I will. Let's just do that. I might just change that to 15. And that means I'll have to change this to 15. And I'll have to change this to 15. Alright? And I'll change this to 15 as well. Okay. And so now I'm just going to zoom in just to have a look. Oh yeah, look at that. It's at the top. Perfect. Right? Because I want to do a good job. And then I'm going to write symmetry. My Sine model has a line of symmetry through x equals 50, and I'm going to just write x equals 50 to show you that. And once again, I'll make it orange, dashed. Yeah, see, that's a model that's symmetric. And then for me, the last thing is I'm going to say the x-intercepts. My model has 2 x-intercepts. 0, 0, and 0, 100. Okay, once again, I know there's more intercepts as I go and zoom, but this is what my domain has restricted it to. And so once again, I finished modeling. Right, I have my equation, and make sure I write this out in full on paper. I have my domain, I have my range, I have my turning point, I have my sine model, and I have symmetry, and I have my x-intercepts. This is how we model. And depending on how your curve looks, you might change your model up a bit or down a bit. But I hope that makes sense to you. Now, on Thursday, when I talk about fit, we're going to talk about how we could probably change our models just a little bit to make sure we have better fit. But I think when you look at my 3 models, I've done a fairly good job. Now, wrong question. Now here's another arch that I could model. I could model with a cosine, with a sine, a parabola, or a cubic. And I could go through and model as many times as I want and to see if I can get better. Sometimes my models are really good and sometimes my models are really bad. So it's okay. So let's try one more. I'm going to start with a parabola model. F of x is equal to k x minus m x minus n. Okay, and for me, it's really important that I know that my x-intercepts are at 0, and in this case at 49, and I need to know that k is going to be a negative number, and it's going to be about, keep making it smaller until until I get a model that seems to work nicely. And for me, what's really important is not it fitting everywhere. So this is a bad model for me. This is a really good model, I think, because I want something that fits quite well in some sections, but doesn't necessarily fit everywhere. So I'm going to say my model is really good in some places and really bad in other places. And that's why I want you to focus on it fitting the curve nicely. And then you go through, write your properties, but I'm not going to go do that again. I'm going to leave this for you to do. So hopefully you found this helpful. This activity is available for you to do. There was a couple of typos. I apologize. But give this a go. Talk to your teacher and see if this makes sense to you. Yeah. So this is how I want you to focus on modeling. It's not guess and check, and it's not estimation. It is a process of iterative refinement. You're making better and better approximations. And as mathematicians, not every value is calculated. And so I think it's okay to estimate and grow smaller or larger depending on what you need to do to make something fit. And depending on what part of this model you're fitting, it's really important. So now I'm really focusing on fitting this side and coincidentally this side. But I could have spent a long time trying to fit the top. And if I'm trying to fit the top, I probably would spend a lot more time figuring out how to fit it. But I don't necessarily think that's a good, sure, it fits at the very top now, but it doesn't fit anywhere else very well. And that's something to keep in mind, okay? So, that's enough of this. If you have any questions, please ask. Otherwise, I'm going to end the stream. Once again, if you'd like to have a go at this, this is the slide you need to have a look at. Okay. No one's asking questions, so I think I will end the stream. Thank you, team. Catch you later.